Good afternoon. My name is Harshal Patil, Division A, Batch 3. Our ECA lab project is over voltage protection circuit using op-amp comparator. This circuit helps protect electronic devices from getting damaged when the supply voltage becomes too high. Next slide is introduction, op-amp comparator. An op-amp comparator compares two voltages, the input voltage and the reference voltage. If the input is higher than the reference, the output becomes high. If the input is lower, the output becomes low. Third slide is op-amp comparator for overvoltage protection. In the protection circuit, we set a fixed reference voltage. The op-amp constantly monitors the supply. When the voltage is normal, the output stays low. But if the input voltage crosses the safe limit, the output switches high and it activates protection like a relay, MOSFET or LED. And the next slide is objective. The main objective is to study how an op-amp comparator works and design circuit that can sense when voltage becomes too high. We also observe how the output changes exactly at the threshold.
The aim of our project is to design and simulate an overvoltage protection circuit using an op-amp comparator. The main purpose is to understand how the comparator detects when the voltage crosses a safe limit and to show how this circuit prevents damage to electronic loads by acting at right moment. This kind of protection circuit is widely used in real-world systems. For example, it prevents overcharging in battery chargers, provides protection in power supplies, protects solar charger controller from excessive voltage. The objective behind our design includes understanding how an op-amp works as a voltage threshold detector, creating a sensing circuit using a stable reference voltage, and then simulate the behavior to see how the output switches when overvoltage occurs. Before designing, we studied how an op-amp comparator behaves. The input voltage is first scaled using a divider and then compared with a fixed reference value. As long as the input is below the safe limit, the comparator output stays low and the MOSFET remains off. But the moment the voltage exceeds the preset threshold, the comparator output switches high. This turns the MOSFET on and activates the LED indicator, showing that an overvoltage condition has occurred. After this, the main circuit implies which protect the overvoltage circuit. Hence, we have successfully simulated the overvoltage protection circuit using multisim. Thank you.